Now I have to calculate this C12 to show the relation between V1 and V2. What is the amount of error is F1 of t minus C12 F2 of t. For a good approximation of F1 of t and F2 of t, this C12 must be minimum. This C12 must be minimum. So, to find the approximation between two signals, we calculate average of the signal, and if average is 0, we can say both signals are good approximation. If not, they are not approximated correctly. So, for finding the approximation, we can calculate its average, function average. So, average is nothing but integration of the function and divided by time. It gives average. So, if I find average of the signal in the interval t1 to t2, it is like this: t2 minus t1, f1 of t minus c12 f2 of t dt. But there is a problem here, which is if I approximate f1 of t a sine signal with f2 of t a null signal, which is a 0. The answer we get is 0. Which means the two signals are equal. But we know that sine signal is not equal to null signal. So this way of calculating minimum error is not good approach. So we go for mean square error, finding the mean square error. We find mean square error to find the similarity of f1 and f2 of t. So mean square error is calculated as, so I am representing mean square error as epsilon, which is 1 by t2 minus t1 integral from t1 to t2. Mean square error f1 of t minus c12 f2 of t whole square dt. So mean square error nothing but average of squares. So to get the minimum error, mathematically we differentiate the function with respect to c12 and equate it to 0, because c12 decides the similarity. Similar in vector, I differentiate it with respect to the standard figure 1 and 2 and 3, where the error is minimum when C12 is perpendicular to it. So C12 is deciding the similarity between F1 and F2. So we differentiate for minimum error d epsilon by d C12 and make it equal to 0. For getting the C12 relationship between F1 and F2. So if we perform this, d by d C12 1 by t2 minus t1 integral t1 to t2 f1 of t minus c1 to f2 of t whole square dt. So, and make it equal to 0. Make it equal to 0. After changing order of integration and differentiation, and differentiation, I can write the same equation as integral t2 by t1 minus t1 to t2 1 by t2 minus t1. So d by d c12 of f1 square of t minus d by d c12 into 2 f2 c12 f1 of t f2 of t plus d by d c12 into c12 square f2 square of t dt equal to 0. So since this term do not contain c12, it is treated as constant. Differentiation of constant is 0. Here there is a c12 term, here there is a c12 term. So we can differentiate these two, but here the result is 0. So integral first term becomes 0 minus here on differentiation 2 f1 of t into f2 of t plus here differentiating 2c12 f2 square of t dt equal to 0. So here term becomes 0 and the remaining term is only two terms. If I take one term other side to 0, the remaining term is, so 2 get cancelled. 2c12 f2 square of t dt integral equal to integral 2 f1 of t, okay, square square, this is f1, this is f2, okay. So I am writing this term first, 2c12 f2 square of t dt is equal to 2 integral f1 of t f2 of t dt. So if I cancel 2 and take constant c12 outside, I can write c12 is equal to integral f1 of t into f2 of t dt divided by integral f2 square of t dt. C1 to expression which gives the similarity between function f1 of t, f2 of t. If they are orthogonal, two signals are orthogonal, this product, numerical product becomes 0. If f1 and f2 are orthogonal, then f1 of t into f2 of t dt is equal to 0. So similarly, c12 is equal to 0. We can say that two signals f1 and f2 are orthogonal. So for obtaining the orthogonality condition in signals, we first analyze the vectors by comparing two vectors After that, we came to signals. We compared two signals and found the orthogonality condition for two signals to exist. Thank you.